Hello, this is Mickey. Today I'm going to show you about the architecture and evolution around 5G. So the evolutions between 1G to 5G. So when we started 1G in 1981, we had a frequency of 30 kilohertz and a bandwidth of 2 kilobytes. And the only thing that we could do that time was how to call. Then in 1992, 2G came out, where we had around 1.2 gigahertz of frequency and around 14.4 to 64 kilo bits in the bandwidth. And that's what allowed us to do calls and video that time. Then in 2001, the internet came in the picture. So based on that, the frequency increased to 1.6 and 2 gigahertz, sorry. And then the bandwidth became 2 megabytes. Then in the 2011, we got the internet, but we also got video calls and everything with around videos. So then aside from that, the frequency also increased between 2 to 8 gigahertz, and the bandwidth went up as well to 2000 megabit to 1 GPS, and that means billions of bit per second. And then we came to shit, that's just what's then we came to 5G recently, and that was brought more frequency and bandwidth. So the frequency can go up between 3 to 30 gigabytes, but and the bandwidth can go more than 1 GPS. So you can see how the revolutions have been changing throughout the time period for the last couple of years, last 50 years. Sorry. So talking about the 5G architecture, that's to start off. So there's two types. That's the control plane and the user plane. In the user plane, it's the UE, so the phone, the radio, and then there's a UPS, and then the internet. So, and then in the control plane, there's the phone or device will connect to the AMF. It does also connect to the radio, and then the radio connects to the AMF. So basically, the control planes it's like your plane side of the core. And there's a small the user point of view to think of it like that. So the way we could look at soon around AMF, SMF, AUSF, and UPF. But the main thing to know is the device to connect to AMF. That's the main one, management function. It'll be under N1 interface. And then this will be under N2 if you go into the LAN to the AMF. If you're going to LAN, straight to LAN to the UPF to the internet, those will be N3 and N6. And then between the session management and UPF, those will be the N4. So AMF stands for Access and Mobility Management Function. The access and mobile management function is a key component in 5G and beyond. Beyond means 6G once we get there. And it plays an important role because it helps to manage the user's access to mobility, the session established within the network. So some key features, like I said, it's the access management, which one controls the user's authentication and authorization of the device. Another manage all the security features, such as keys and encryption setups. In mobile, that's also mobile manage mobility management, which tracks the movement of the device between the different base stations. So it's like cells, and it handles the handovers between the cells to seamlessly to continue connectivity. And the last thing is the main function it has, it's the session management. Establish and maintain user session to link the active connection and also manage the QoS parameters for optimal user experience. So QoS means the quality of service. So when we look at the AMF messages, some may include the registration request, which means that initiate the connection between the UE and the AMF, and it contains the UE identity and internal capabilities. Then you would to an accept the message, which when would accept UE registration request and establish a communication parameters. Then you would to a tier registration, which is where two UE request its connection between the network and can be integrated by UE or by the network conditions. Other methods include to accept the tier registration from before. So this was a request. Now you would to acknowledgement and it leads the results associated with the UE. Then there's the handover request, which when the UE will request a handover from the source cell to the target cell and includes necessary information for the handover. And then you do a command where AMF will command the UE to perform the handover and provide the details related to about the target cell. And then the last thing I would hand over to you too, it's acknowledgement. And that's where the UE will acknowledge the AMF command. And then it confirms it can read and everything. And then once all it's done, so before it was the acknowledgement, now we're going to complete it. And that's where the UE confirms that successfully it been afterwards been completed, and AMF updates the UE's location in the network. After the handover, another message will come, you can do it's paging, where AMF iterates paging to the locate a UE the for the incoming calls or data, and it informs the target cell to start the connection setups. So once the paging gets done, then you need a response to happen, and that's where the response comes in, where the user is responding to the paging message above, and it's indicating its availability to establish communication. After you've done all the paging, then we are looking at the service request. So service request, it's specifically for the network. So the UE setting methods of the services, and it includes like service identity and requirements. Once the request comes, then you have to do an acceptance. So the AMF accepts the UE request and grants access to requested services. If for some reason it does not give proper identity or anything, you will get a reject. And so AMF will send the UE a reject, and then it will provide some reason for the rejection. Another method you can get in the AMF are locations, request updates, and location accepts. So location request, just set in the UE updates to the AMF about your location, and this occurs to link mobility events. And accept it just acknowledging the UE location updates, and it's updating the UE location in the network. Okay, so then if we come to the next like methods group, the function. So the next one we could look at is user plane function, which is a vital component in 5G and evaluate packet core EPC networks, because it's responsible allowing the data traffic between the device and external data. So some key features, it's data forwarding. So UPF facilitate and evaluate data between the UE and the external network, and it ensures a low latency and high accuracy data transfer, critical for the application for streaming real-time communication. And also touch the QoS management. So it's measuring the QoS calls. It's enforcing uh, and the QoS policy to allocate networks resources based on the requirements, of course. And it also ensures like the user's experience based on the bandwidth and like its based on the services. And the last main feature around this function, it's all about traffic and policy shaping. So the actor, it's talking about more on like performing traffic policy to monitor incoming data and control traffic exceeding defined limits. So based on the limits, based on what's coming in, it will perform the policies. And then the data shaping, it's regulated around data flow, which prevent network concentrations and maintain smooth data experiences. So some measures that could come in the UPF, it's a downlink data notification. So it's a sensor by the SMF to notify the UPF about downlink data arrivals based on the Pacific UE, and it contains information about the data packet and its associated context. Then there's going to be uplink data notification as well, but it's going to be the same thing, but instead of SMF sending it, it'll be the UPF sent it to the MSF, indicating the availability of uplink data of the UE, from the UE. And this includes information about the data packet and its context as well. Then there's the downlink acknowledgement, which it's saying, okay, UPF, it's like a message saying, yes, I acknowledge to the SMF upon delivery of the downlink data to the UE. And it will provide the status and provide like status about the transmission data. And in there's also uplink acknowledgement, which one the SMF acknowledge the receipt and uplink data from the UPF, and it indicates a successful data handover. And messages can come along the context modification, which used to modify the QoS or any other parameters, and it is indicated by the SMF and processed by the UPF. So then we go to session management control function, which one you've seen before, which is the SMF. This is a critical component in 5G because it's because it provides, it keeps track and manage all the user sessions and connections. So some features that might be included maybe like a session establishment and termination, where SMF will be responsible for creating, modifying, and terminating user session in that network. QoS, so to ensure proper QoS levels and maintain the different service and application. Policy enforcement. It enforces it can enforce like network policy to ensure compliance with the service level agreement, network rules. There's also user and control plane separation. So it helps separate based on user plane and control plane function and enhance network efficiency and flexibility. Then there's mobility management, where SMF will manage the user mobility and seamlessly, so from the base station and the network nodes. And then there will be also pair management. It handles establishment, modification, deletions of pairs which communicates channels on specific services. So you can think of this as your second, after AMF, your second main management function that you need in the core of 5G. So some methods that could come will be like create a session request, which establish a new user session, which includes the user's request, request, session parameter. It could be about the user. And then once you create a session request, there will be a session response, which will respond to create the session request, and it indicates whether the session was successfully established or any issues encountered. Once the update all that happens, then let's say if you want to update existing sessions, then you will can write the message around update session request to request a modification to existing sessions such as QoS updates or any other resources. The same with when you send a request as previous slide, you need to put a response happening to inform if it's failing or not with of the modifications. And then once the termination, there will be termination session request and response. So if your deletes are like it's initially a termination of any active sessions, and they will provide the details about the session being terminated, and then response is it's telling if it's successful or not session termination of that session. Then we will get that our methods talking about like modifications, where if let's say if a session let's say a network get triggered with modification, it would first do the command to send or to change it in the active session. Then, but since you made the changes, you need to have a acknowledgement, and that would be a modification complete message. And the modification complete session will iterate and be mainly to say, hey, that the command modification command has been completed or did not complete and successful. After you done that, there will be methods around release access payload request and release access response. These are like your access pair associated intercessions, and then that's go. So that will request a release, and then for the response will either respond indicating if it's successful or not for the pair release. And then the last one we can look at for today, it's authentication server functions. The authentication server function, it's another key method of 5G and next generation network, now also called future network, just to let you know. It's mainly provide the authentications and security services. So some features may be like authentication and key management around managing authentication related procedures and key functions for secure connections. That what the authentication and key management function will do, and it will also provide subscription information repository. So it stores auto subscription data, authentication credentials, and authorization information. So some possible methods may include like a UE authentication request, where it's sent by the UE to integrate the authentication process, and it can contain like the UE's identity, security contact. Another authentication methods that it can provide is around the authentication information request, where it gets the request from AUSF, so authentication server function, to the HSS, which is your home subscriber servers, to retrieve authentication information. And it includes like UE identity and component authentication parameters. UE authentication response. So after you send the request, there will be a response where the AUSF to the was sent to the UE to make sure the authentication is successful, and this contains like security related information to make sure the UE connections secure and it's happening fine and also. So after the another methods that could come, it's authentication information asset. So that means that each assets, so each assets, if you go back, it's your home server, subscriber server. It's responding to the authentication server function. And this can include the authentication methods like related information about a UE authentication. There's also if let's say for some reason it failed, then getting information from the authentication server to the UE, then you will get failure messages and you will you will show unsuccessful authentication and it will potentially tell the next steps. And then once that's done, you can also do an update the authentication information. So let's say if you want to change information, so in some let's say from the server side, then you can request from the AUSF to the HSS to update the authentication information by triggering by events like key material expiration, security context change. And then there will be also the answer that will happen, which is sort of like the response, where to make sure everything is responding. And then it will also tell that it contains the new authentication vectors and data for ongoing like communications that happens. And yeah, that's all for today. Thank you. If there's any questions, you can put in the chat. Thank you.